this kit is LGEC003, which is called DTMF based messaging. So we have made a kit in which we have shown a method to display any message on this LCD with using DTMF tones, which are generated through this DTMF device. Now there is this DTMF decoder IC which receives the DTMF tones through this device and then converts them into binary signals and supplies those binary signals to this 8051 series microcontroller. Now this microcontroller is programmed in such a way that the output is displayed on this LCD correspondingly. So let me show you working of this particular kit. So you have to use your remote cell phone to give a call on this DTMF device, and then you need to use your cell phone, and whenever you press any key on your keypad, so the corresponding DTMF tone is generated on this cell phone, and this is transmitted to the DTMF decoder, and the corresponding message can be seen on this LCD. So this works as the same way as you type any text message, and the same letters will be displayed on this particular LCD. So this works on the principle of DTMF technology, where the DTMF tones are produced on this device, and then those are converted into display output. And you can order this kit from our website www.kitsguru.com, where you will find two versions of this kit. One is a complete assembled kit where you will get this entire ready-made kit, and the other one is a complete breakdown kit where we'll give you all the components along with the PCB and the program microcontroller, where you'll have to assemble the kit and solder it yourself with with the help of a video tutorial which we have provided in our website. In this section of the video, we'll tell you about the different components used in this kit and also explain the function of each and every component, and how do we assemble the components together, and how do we convert a set of components into a working kit. Okay, for that, first we'll look into the main PCB board. Now we have a ready-made kit here as a reference. So we can refer this particular kit and then assemble each and every component together and see how it works. So there are basically four sections in this PCB. One is the section of the power supply, which is this, the top part. And then the second section is the DTMF decoder IC and their corresponding components. The third section is the microcontroller and their components. And the fourth section is the LCD section. Okay, so first we'll start off with the power supply. Now, first we have a power jack here, so we'll fix the power jack. Now we have to make sure that we keep the PCB, the raw PCB corresponding to the particular kit, and then assemble each and every component together. So first we'll insert the power jack. Now this PCB has two layers. This is the top layer and this is the bottom layer. Okay, the top layer is the part where every component is inserted, and the bottom layer is the part where the copper tracks are present and the soldering takes place at the bottom layer. So this technology on which this PCB is made is called through hole technology, where the holes are drilled throughout the PCB from the top to the bottom layer, and then the components are fixed from the top side and it is soldered at the bottom side. So first we'll fix the power jack. Okay, then we fix the on-off switch, which is a 6-pin switch. This does not have any direction. So this is to switch on and off the circuit. Now then we have a bridge rectifier. Now a bridge rectifier is used to rectify the AC input. Suppose you give an AC supply or supply from the transformer. So this bridge rectifier is used to convert the AC into a smooth DC output. So when you look at the bridge rectifier, you will notice that there are 4 pins at the bottom, and corresponding to these 4 pins on the top are 4 terminals. So one is positive, the second one is negative, and 2 AC signals. So these 2 AC signals represent the input signal, and the positive and negative represent the output DC signal. Okay, so while fixing the bridge rectifier, you need to make sure that the positive terminal is at the top right of the 4 holes present. Now the positive terminal is the terminal which has the longest stem, as you notice. So you have to make sure that it goes at the top right, and corresponding terminals fix in the same way. And then we use a electrolytic capacitor. Now this electrolytic capacitor is used to remove all the AC repulses which are produced during the rectification process. Okay, so this also has a positive and negative terminal to it. The stem which is longer in length is the positive terminal, and the shorter one is a negative terminal. By chance, if both the stems are of equal length, then there is this blue strip which has a negative indication on it, so which tells you that this is a negative terminal. So while fixing the capacitor, connecting the capacitor, you need to make sure that the negative terminal is facing you, so that the positive terminal of the bridge rectifier is in line with the positive terminal of the capacitor. Okay, then we have a 2-pin connector. So a 2-pin connector is used, it is not used in this particular kit, but sometimes you need to connect another PCB and give a direct 12 volt supply to it, so we can use a 2-pin connector to do the same. Okay, then we have a voltage regulator IC, which is 7805. So this is used to convert a 12 volt DC input to smooth 5 volt output. So when you keep the voltage regulator IC in front of you with the technical specifications written on it, so this is the front face. So the left terminal is the first terminal, then the second terminal in the middle, and the third terminal on the right. So while fixing this voltage regulator IC, you need to make sure that the front face is facing you. Okay, so now we have finished the section of the power supply. So now we'll come on to the section of the DTMF decoder IC. So DTMF decoder IC, before fixing the IC, we'll provide you a base. Now the base is provided so that the IC does not get damaged during the soldering process, or in future if the IC needs to be replaced, you can remove it and replace it easily. Now you'll notice that the IC, when you keep it in front of you, you'll notice that there is a notch on the top side. Okay, when you keep it vertically, there's a notch on the top side, or a small hole on the top side. So this is the top side, and the left pin on the top is the first pin, and then we count the pins in the counterclockwise direction. So the right pin on the top is the 18th pin. So this is how you count: 1, 2, 3, 4 on this side. This is the 9th pin, and so 10 to 18 on the right side. So the same way, while connecting this, you need to make sure that the notch is on the right side, the base notch of the base is on the top side, and then you need to fix the base first, and the same way the decoder IC goes on top of the IC base. Okay, then you need to fix a crystal oscillator of 3.5 megahertz. This crystal oscillator decides at what frequency the decoder IC works. So So the crystal oscillators goes here, and to start the oscillation process, we have provided you two capacitors of 33 picofarad, which has to be connected just next to the crystal oscillator parallelly. Okay. Now after that, we need to connect an IC104 capacitor of 0.1 microfarad, which is here, as you can see. And two resistors of 100 kilo ohm with color code brown, black and yellow. The resistors goes just next to the 0.1 microfarad capacitor. Then we need to connect the input jack for the audio input, so which goes just next to the 0.1 microfarad capacitor. This does not have any direction. You can connect it in any direction you want. And on the right side of the IC base, you can see one more capacitor of 0.1 microfarad. These components are compulsory components which needs to be fixed along with the IC so that the IC works smoothly. And then we have a resistor of 330 kilo ohm with color code orange, orange, yellow. Now we need to fix an LED. Now this LED is the power indicator LED. So the LED has two terminals, positive and negative. So the stem which is longer is the positive terminal and the shorter one is the negative terminal. Sometimes when the stems are of equal length, you'll observe usually the LED bulb is round in shape, but at the negative terminal you'll see the bulb gets flattened. So the bulb gets flat. So that indicates that that is a negative terminal. So while connecting the power LED indicator, you need to ensure that the negative terminal is on the right side. Okay, and then we connect a resistor of 1 kilo ohm along with this LED. This has a color code of brown, black and red. So this is usually provided to protect the LED from getting damaged. And along with this, you'll see a bridge, normal wire, a metallic wire. Now sometimes what happens is you cannot create tracks at the bottom layer. So we have provided you with wires so that you can connect from the top. You can connect, you can give a connection from the top. Okay, so this completes the DTMF decoder IC circuit. Now we'll move on to the microcontroller circuit. So the microcontroller base also has a notch. So you'll see it has a notch, and this notch has to be present on the right side. So as you can see here, the notch is present on the right side. So while fixing the base, you need to make sure that the notch is on the right side. And the same way, the microcontroller, when you keep it with the notch at the right side, the top right pin of the microcontroller is pin number 1, and counting counterclockwise, the bottom right pin is pin number 40. So this is mounted over the base like this. Okay, then this microcontroller has a crystal oscillator of 10 megahertz, which fixes here. And along with the crystal oscillator, we'll fix 2 capacitors in parallel. Now we need to connect a switch, a reset switch. This reset switch always helps us to reset the microcontroller whenever we want. So this goes here, and along with the reset switch, we need to connect a resistor of 10K, which has a color code of brown, black and orange. So the resistor goes here. Okay, so after the switch and the resistor is connected, we'll connect a network resistor. This is a 10 kilo ohm network resistor. A network resistor is a set of resistors combined together. So it helps us in saving space. Now when you keep the resistor in front of you, you'll notice that there's a dot on the left side of the resistor. So while fixing the network resistor, you need to make sure that the dot is on the left side and the resistor is facing you. Okay, so this completes the section of the microcontroller. Now we'll move on to the section of the LED. So first we'll connect the base of the LED. So this is a birth strip male type. So usually the birth strip does not, if the birth strip does not go at one go, you can break the birth strip and insert it separately. Okay, and on top of the birth strip, we'll fix the LED. The LED is fixed with the help of a female connector. This is the female connector. The female connector is soldered on the LED like this, and then this entire assembly sits onto the LED. Okay, once the LED is fixed, LCD is fixed. Now we need to connect the LED, which indicates the signal, the output signal. So this is the LED, and the negative terminal of the LED is on the left side. So this is how it goes, and the resistor, the supporting resistor, is fixed along with the LED. And at last we'll connect a potentiometer. Now this is a 10K potentiometer which is used to adjust the brightness and the sharpness of the LCD display. So once this circuit is complete, the connections are done, you need to solder each and every component, and then before fixing the IC we need to make sure that the connections are proper and the power supply is given properly, and the power to each component is proper. So for that we'll use a multimeter, and first we'll fix the black terminal to the common terminal of the voltage regulator IC. Now the top part is the common terminal of the voltage regulator IC. So the input to the voltage regulator, as we know, is the AC input, so which is around 12 volts, but it is coming down because of the bridge rectifier. And the output from the regulator IC is 5 volt as we require here. Okay, so now we need to check the signals or the output power signals at the DTMF decoder IC. So we'll check the last pin. So pin 18 should show a value of 5 volts, and pin 40 at the microcontroller should show a value of 5 volts. So it is correct. And the second and the second last terminal of the LCD should show 5 volts. So once this the power is checked and the power values are checked, you can solder you can fix the ICs and and start the circuit. Now we'll also give you a power jack. This is a power jack which can a 3.5 mm jack which can be connected to the DTMF device. Now to connect the jack, once you open the jack, you will see there are 3 terminals. So one wire can be connected. Now this is the wire which has to be connected. So one wire can be connected to the longest terminal, and the second wire can be connected to the second longest or the second largest terminal. So once you fix this, the connector, the other end of the connector can fix into the 2-pin connector here, which we fixed earlier for the sound input. So once this connection is done, then you can check the connections and you can check whether the kit is working or not. So right now the connection So once the DTMF device detects this jack, as soon as you press any key, you can see the letters being displayed on the LCD screen. So in order to achieve this kit, in order to buy this kit, you can visit our website www.kitsguru.com and check our video tutorials for soldering and how to assemble these components, and to order this kit or to order similar kits, you can visit our website and buy online. And hope you've enjoyed this video.